What if I told you there are cosmic phantoms hiding in the universe since the very first second after the Big Bang? I'm not talking about science fiction. I'm talking about black holes that might have emerged when the universe was just a fraction of a second old. Black holes so tiny they could fit in the palm of your hand, yet as massive as an entire mountain. And here's the most fascinating part. These mysterious objects could be the key to solving one of the greatest enigmas of modern cosmology, the dark matter that makes up 85% of all matter in the universe, but which we've never been able to detect directly. Today, we're going to dive into the extraordinary world of primordial black holes, explore how they might have been born in the universe's earliest moments, and discover why scientists worldwide are dedicating their careers to finding them. I'll show you incredible experiments happening right now to hunt for these cosmic relics. And by the end of this video, you'll understand why the discovery of these objects would be one of the greatest scientific revolutions in humanity's history. Hello, cosmic explorers. Welcome back to Cosmic Frontiers, where every video is another step on our fascinating journey towards 1,000 subscribers. Get ready for a trip back in time to the universe's earliest moments. To understand primordial black holes, we first need to go back to the Big Bang, but not as you probably imagine it. Forget the image of a giant explosion in empty space. The Big Bang was more like the entire universe expanding from an extremely dense and hot state. Imagine a grain of rice containing all the mass of the observable universe. That was the density in the first cosmic moments. In the first microseconds after the Big Bang, the universe wasn't uniform like a well-mixed soup. It was more like a pot of popcorn popping. There were regions slightly denser than others. And here's where the story gets interesting. If a region was dense enough, it could collapse in on itself due to its own gravity, forming a black hole even before the first stars emerged. Think of it as a race between two forces, the expansion of the universe trying to spread matter out, and gravity trying to pull it together. In most places, expansion won, but in some special spots, where matter was too concentrated, gravity was stronger, and boom, a primordial black hole was born. The British physicist Stephen Hawking was the first to seriously propose this idea in the 1970s. He realized that, unlike the black holes we know today, formed when massive stars die, these primordial black holes could have any mass, from microscopic to millions of times the mass of the Sun. It's as if the young universe was an uncontrolled factory, producing black holes of every imaginable size. Now, you might be wondering, how can something be smaller than an atom and still be a black hole? Here's the beauty of physics. It's not the size that matters, it's the density. A primordial black hole with the mass of a mountain would only be the size of a proton. Imagine taking the entire Mount Everest and compressing it until it's smaller than an atom's nucleus. That's the absurd density we're talking about. But here comes the most thrilling plot twist in our cosmic story. Remember the dark matter I mentioned at the beginning? That's one of the biggest mysteries in modern cosmology. We know it exists because we can see its gravitational effects. Galaxies spinning faster than they should. Light from distant galaxies being bent by something invisible. But what on earth is this dark matter? Scientists have proposed all sorts of exotic particles to explain dark matter. WIMPs, weakly interacting massive particles, axions, sterile neutrino. But what if the answer was right in front of us all along? What if dark matter wasn't a mysterious particle, but rather primordial black holes scattered throughout the universe? Think about it. Black holes are literally dark. They don't emit light. They have mass, and, therefore, gravitational effects. And if they exist in sufficient quantity, they could perfectly explain all the dark matter we observe. It's like discovering that the monster you thought was hiding under the bed is actually just your forgotten socks. The answer was there all along, but you were looking in the wrong direction. The math is fascinating. If primordial black holes with masses between 20 and 100 times the mass of the Sun were scattered throughout the universe, at the right density, they could constitute all of dark matter. Imagine that. All this cosmic mystery that has intrigued us for decades could be solved by objects born in the universe's earliest moments. But how on earth do you look for something that is, by definition, invisible? This is where scientific creativity shines. Scientists have developed ingenious strategies that would make any detective envious. The first strategy uses something called gravitational microlensing. When a primordial black hole passes between us and a distant star, its gravity acts like a cosmic magnifying glass, temporarily brightening the star. It's like using the black hole itself as a tool to detect it. Projects like Marcho and Eros have scanned millions of stars looking for these amplification events, finding some intriguing candidates, but not enough to explain all of dark matter. The second strategy is even more spectacular. Gravitational waves. When two primordial black holes meet and merge, they create ripples in the very fabric of space-time. The LIGO and Virgo detectors have already captured dozens of these mergers, and some have characteristics suggesting that at least one of the black holes involved could be primordial. It's like hearing the echoes of events that happened when the universe was in its infancy. There's also a fascinating strategy that uses Hawking himself, so to speak. Hawking discovered that black holes aren't completely black. They emit a very faint radiation due to quantum effects. Smaller black holes emit more radiation and evaporate faster. A primordial black hole with the mass of a mountain would take longer than the age of the universe to evaporate, but one the size of an asteroid would have exploded long ago, releasing an enormous amount of energy. Gamma-ray telescopes in space constantly search for these primordial explosions. So far, they haven't found any, which tells us something important about how many small black holes exist, or rather, how many don't exist. The most ambitious experiment is happening in space with the Gaia telescope. This space observatory is mapping the position and movement of over 1 billion stars with unprecedented precision. If primordial black holes exist in sufficient quantity, they should subtly influence the movement of nearby stars through their gravitational effects. It's like detecting the presence of a phantom by observing how objects around it behave strangely. On Earth, underground experiments like Xenon and Lux, originally designed to detect dark matter particles, are now also looking for signs of extremely small primordial black holes passing through Earth. If a microscopic black hole were to traverse our planet, it could create a detectable signal in the ultra-sensitive sensors of these experiments. Recently, a new strategy emerged using pulsars, rapidly rotating neutron stars that emit radio beams like cosmic lighthouses. If a primordial black hole were to pass between us and a pulsar, it would cause a tiny distortion in the arrival time of the pulses. Radio telescope arrays around the world are monitoring hundreds of pulsars, creating a galactic network of primordial black hole detectors, but perhaps the most intriguing evidence comes from where we least expect it. In 2020, the LIGO-Virgo collaboration detected the merger of two black holes with very peculiar properties. One of them had about 85 times the mass of the Sun, a mass that theoretically shouldn't exist for black holes formed by stars. This is because very massive stars undergo a process called pair instability that prevents them from forming black holes in that mass range. But if it's a primordial black hole, these restrictions don't apply. It's like finding a dinosaur fossil in rock layers that should be too old for dinosaurs. It makes you question your basic assumptions about how things work. Another fascinating point is that some theoretical models suggest that primordial black holes could explain not only dark matter, but also the seeds of the supermassive black holes we find at the center of galaxies. How do you make a black hole millions or billions of times the mass of the Sun? One possibility is to start with massive primordial black holes that grow over billions of years, swallowing matter around them. The search for primordial black holes is more than a scientific hunt. It's a journey to understand the universe's earliest moments. If we find them, we won't just solve the mystery of dark matter, but also gain a unique window into epochs of the cosmos that we can never observe directly. The universe of the first microseconds is like a lost city in archaeology. We can't go back in time to visit it, but we can find artifacts that have survived to this day. Primordial black holes would be exactly that, preserved relics of the most extreme moments in cosmic history. Imagine the revolution it would be to discover that objects formed when the universe was less than a second old are still out there, influencing the structure of galaxies and holding the cosmos together through their invisible gravity. It would be like discovering that the DNA of a primitive bacterium is still active in your body, influencing how you function today. So, cosmic explorers, here are the 3 most fascinating points from our journey today. First, black holes may have formed in the universe's earliest moments, when everything was extremely dense and the laws of physics manifested in ways we can barely imagine. Second, these invisible objects could be the dark matter that has intrigued us for decades. The answer to one of modern cosmology's greatest mysteries could be hidden in relics of the Big Bang. And third, right at this moment, Scientists around the world are using incredible technologies, from gravitational wave detectors to space telescopes, to hunt for these cosmic relics. The search for primordial black holes reminds us of something profound about our human condition. We are beings made of stardust, trying to understand our own origin by looking into the darkest and oldest corners of the universe. Perhaps the dark matter that permeates the entire cosmos, including the space around us right now, is composed of gravitational phantoms born when time and space were still learning to exist. If primordial black holes are indeed discovered as constituents of dark matter, it would mean that we are literally immersed in an invisible network of objects formed in the first moments of creation. Every breath you take, every step you take, happens in a universe permeated by these primordial relics. Isn't that absolutely extraordinary? Now I want to hear from you, cosmic explorers. If we could truly prove that primordial black holes are dark matter, would that change the way you see the universe around us? Leave your reflections in the comments. I love reading your perspectives on these cosmic mysteries. And speaking of mysteries, what phenomenon of the universe do you want me to talk about in the next video? Perhaps about the universe's first stars, the strange objects called magnetars, or who knows, about the possibility of parallel universes. Leave your suggestions in the comments. We're on an incredible journey towards 1,000 cosmic explorers. If this video sparked your curiosity about the universe's deepest secrets, join our crew by clicking subscribe. Every new explorer brings us closer to our goal and makes our community even stronger. Like this video if it expanded your cosmic horizons, and share it with someone else who loves the mysteries of the universe. In the next video, we'll explore another fascinating phenomenon that challenges our understanding of reality. Don't miss it. Until then, keep looking at the stars and remember, the universe is far stranger and more wonderful than our wildest imagination. See you at the cosmic frontiers.